Okay, hello, here we go with the chain rule, a very important way to differentiate and certainly one of those things that you need to be very clear about. It crops up everywhere, including with the product rule and quotient rule. So let's get started. Before you can do the chain rule, you need some idea of basic results. If you don't know your basic results, then you can't do the chain rule. X to the power n differentiates to cosine of x differentiates to sine of x. You must be able to differentiate all these things before you could start the chain rule and natural logarithm. So we've got x to the n differentiates to nx to the n minus 1 cosine of x differentiates to minus sine of x. Sine of x becomes cosine of x. Exponential e to the x becomes e to the x, nice easy one, and log x, one to remember, differentiates to 1 over x. So basic results, which is part of the battle. Once you know the basic results, you need to be aware of composite functions. Composite functions, we have an inside and an outside function, a function within a function. So if cosine is the outside, we might have 5x on the inside. Sine is outside, and we might have, let's say, x squared on the inside. E to the power, and we might have inside that x squared. E to the power inside, we might have 3x. Logarithm, we might have inside that 3x plus 2. And powers of x, these ones, watch out for these. We have, let's say, a power of 3, and inside that we could have such things, and negative powers, even more awkward, so something to the power minus 2, and let's say inside we'd have that. So those are composite functions. If you can recognize composite functions, which is what we want to try and differentiate, and you know your basic results, we should be able to get started. So here we go. If we have a composite function, then to differentiate, what we would do is we would differentiate the outside function first, leaving the inside, and then we would multiply by differentiate the inside function. So outside followed by inside. So for example, we know that cosine of x differentiates to minus the sine of x. So if we have a composite, cosine of 5x, then differentiate to minus sine of 5x, multiplied by differential of the inside, 5. Sine of x we know goes to cosine of x, so sine of 3x goes to cosine of 3x, multiply, differentiate the inside, 3. Sine of x squared becomes sine goes to cosine, differentiate the inside, 2x. Cosine of x squared plus 2x. Cosine becomes minus the sine, and differentiate the inside to become 2x plus 2. Multiply. There we go. So inside, outside. E to the x we know differentiates to e to the x, so if we've got a composite, let's say e to the 5x, differentiates, now the inside, 5. E to the x squared, differentiate the inside, 2x. E to the half x, differentiate outside, differentiate the inside. Logarithm, very important one to remember. Now log of x becomes 1 over x when we differentiate, so inside, outside, 1 over 3x plus 2 for the outside, differentiate the inside, 3. Logarithm of x squared plus 5. 1 over every time for the logarithm. and differentiate the inside. There we go, chain rule. And finally, x to the n, we know becomes x to the n minus 1 multiplied by n as our differential. So if we have something to the power 5, we know we're going to get 5 something to the power 4. So if we have an inside function, we multiply by, differentiate the inside, 3. (3x squared plus 2 to the power 7). Something to the power 7 becomes 7 something to the power 6, and multiply by, differentiate the inside, 6x. Of course, you can tidy these up a little bit. We could tidy that one up to 15. 4. We could tidy this one up to 42. We've got an x, and we've got a 3x squared plus 2 to the power 6. Run out of room there. And finally, if we had something like, let's say we had something like 1 over 3x plus 2. Well, we'd think of that as something to the power -1. Differentiate outside. Take one off. Differentiate the inside. And if you want to tidy that one up, 3. We've got a -1 there. And the power is squared and denominator because it's negative. And finally, what if we had something like, let's say, x squared plus 3? Then we'd be looking at that and saying we see an x squared plus 3 inside, a power of -2 outside, so -2 to the power -3, and multiply by, differentiate the inside, 2x. Tidy this up, 2 2s are 4 with the negative and the x, and we've got the x squared plus 3 with the power of 3 and negative, so denominator. There we go. Finally, standard results. There are some very common ones. If we have such things as cosine of 3x, 2x, 4x, cosine of, let's say, a times x, sine of a times x. Now we know sine differentiates to cosine, and we know cosine differentiates to minus sine. Differentiate the inside, we get those results for our differentiation. What about e to the power 2x, 3x, 4x? Well, e to the x becomes e to the x, e to the x becomes e to the x, multiply, differentiate the inside, there we go. And logarithm, finally, logarithm of, put a linear function in there, very common to see. We would get 1 over, and differentiate the inside, so there we go. Some standard, very common results, but our chain rule is that we have a composite, we differentiate the outside, and we multiply by, differentiate the inside. There we go, chain rule.